Okay, there is something happening there at least. Now, yeah, that is back. Hopefully, that should be good. We are back, right, left. Okay, I don't know how many times I have started the stream today, but it's testing the questions. But anyways, let's start. So what I was saying is, I was trying to paste this in Excalibur, but that didn't work. I just crashed my entire system, and I opened teardrop. So this is the input, and this is the initial stage. So it is at, so the first robot is at 2 comma 4. So if you see, 2 is the x coordinate, which will be across. So you can see x coordinate is this, and 4 will be y. So it would be down, or you can see the height of it. So if you see 0, 1, 2, 3, 4, it is at the fourth level, and 2 will be 0, 1, and 2. It is at this, what we say, the width of it. So it is at here initially, and after 5 iterations or 5 seconds, it is at this position. Let's say it is initially at 2 comma 4, and then it is at 0, 1, 2, 3. Um, so it is 1 comma 3, right? So you can see that transformation has happened somewhere there, and we can sort of figure out what will be that, like a number. So it's like an equation, right? We have some numbers that we have some time that happened between them, and we have the velocity. So we can use that formula called, uh, we try to multiply that uh, x component with the number of seconds and add to that the velocity. Okay, so the initial position, so that will be the current x position. So and we need to add. So we first multiply it with how many times you want to do it. So let me call it 2 times 5, right? Because you want to do it 5 times, and then we add this with the velocity which it has. So it is 2, and we need to mod it with the bound that we have, right? It is like, what is the bound? Because this will be within 101 and 103 tiles. So we need to make some sort of boundaries there. So if you see, it is 101 tiles wide, and x that definitely does that thing, right? So if you do this, which will be 10 plus 2, which will be what? 12. But that mod will be what? Be, so that will be bounded with, yeah, I think we need to mod it with that. It will be 101, right? So it will be 12 mod 101, which will be 12, and then we need to, if like it is within the bounds, and then we need to uh, add that component to it, or no? Yeah, So how do we do this? Actually, this was wrong, right? Like we need to multiply the velocity with the time and add the x component and mod it with the boundaries. Hmm. So u times 10 will be 10 plus 2, 4, 101 and 12 mod 101 will be 12. So how do we do this? Scaling position. What is the formula? I'm missing the formula now. So it will be, so we just multiply the velocity, right? So velocity is 2 and 4. Hopefully I've copied it right. 2 minus 3 and after 5 seconds it is at that position. So 2 to 4 and then we move to 1 and 3. Maybe uh, let's do one thing at a time. So let's do it after 2 seconds. So this will be after 1 second. Oh, maybe that was after 5 seconds. We need to copy this one. After 5 second one. So that will be so confusing. So it will be 1, 2, 0, 1, 2, 3, 4, 5, and 6. So 0, 1, 2, 3, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Mm. So why do we get, do we do it like 101 is the bounce? Definitely won't cross, it will cross 2 times, right, in that example. So, okay, we need to add this position to the velocity that it has. Is the boundary given here? Like it was 7 and 11 tiles. Oh, okay. Do we add this mod it with 7, sorry, 11? Then we get 1. No, is it 1? It's not, right? It's 1, right? 12 mod 11 is 1, I believe. It should be. So, yeah, we have to do that. And if we see that second component, so that should be 4, not 4. be minus 3 times 4 plus 4. No, it is uh, so we need the first position and the velocity of y. We need to add the position of this with sorry, what I'm doing here is 5 and this should be 4, and this makes out 15 plus 4, sorry, minus 15 plus 4, that is 11. And what was the boundary? It was 7. So 11 and 7 mod 7, that is 4. However, 50, do we multiply this or 4 plus minus 3, and that brings out 20 minus 7, 13, which will be 17. 17 mod 7 is 3. That's kind of a cheating there, but uh, never mind. Let's take let's take the example of 4 seconds. It is perfectly at 10 comma 5, right? 0 1, so 10 comma 6, 0 1 2 3 4 5 6. So y position is 6, and this is how much? 0 1 2 3 4 5 6 7 8 9 and 10. So we have 10 and 6. So let me write it here. 10 comma 6 is the final position after 4 seconds. So first we need to compute how many times we are, and we add the x component, which is 10, and we multiply 2 here. So that becomes how much? 8 plus 10, which is 18 mod 18 mod 11, which is 7. 18 mod 11 is 7, right? And then this is wrong. We multiply the position first. Now let's, so plus 10 was what? Sorry, plus 10 is not what I wanted to add. I wanted to add oh no. So I want the current position is 2 comma 4. I want to add 2 and multiply 2, 4, 8 and 10. So that will be 10. 10 mod 11 is 10. Okay, that example is confusing because 2 and 2 are same. So that will be tricky. Let's go for the y component, which is uh, so I place it in 4 times 4 and subtract out 3 from it, right? And that turns out to be 16 minus 3, 13. 13 mod 7, that is 6. Yeah, it is 6. Okay, so we need to add the x component or the x coordinate and subtract the velocity, the component of that velocity. I'm not sure if that is true, but yeah, let's try it out. If that comes out to be correct within the bounds, and here we have the bounds as 101 and 103, so I'll remember that. And yeah, so we already have done this. We need to write let's call it teleport or not call, so I'll create, so the first step is, so like I'll call the end output. What we want is, we want uh, like all the robots aggregated into quadrants, but before that we need to find which robot is in which quadrant. So I'll call it place robots, uh, teleport, yeah, or teleport robots. Why naming is such a bad thing? So simulate or simulate robots, which will be a list of point. This will be, and I need to pass in the boundaries as well. Maybe we can hard code that, but let's, if in the part 2 it changes, then I'm not sure. So boundary x and boundary y will be integers. Let's call it width and height. And we will have again list of point. Actually we'll just have a list of point, right? Because we won't have, we don't need the velocity at that point, so we'll just get the point. So yeah, so for robot in range robots, we need to compute the x coordinate. So we'll take it x as robot dot, okay, it is a list. So coordinates, and I have velocity as robot of 1. X becomes coordinates, x, then multiply it with uh, multiply it with what? What did I mention there? Yeah, multiply it with the number of iterations that we want to do. So it will be 100. It was 100, right? And let's not do 100, let's do 5 with that example. And so this will compute that, and we need to mod it with width. Similarly y will be, oh wait, I forgot to add velocity dot x. So this whole thing will be modded with the height, and this will be modded with y, modded with, sorry, height. And that should be it. So we'll create new robots. They are not new robots, but moved robots, list of point, and append to the new moved robots as return more robots. So let me check that out first. Moved points. Will pass in 101. Sorry, this will be 11 and 7. Width is no, width is 7, right? The width is 7, yeah. The height is 11. So we'll print in new move points. So 361106. Let me check. 3 and 6. Let me do one thing. Zero, 1, 2, 3, and 2, 9, 2, 9, 4, 3. Actually, let's do 5 only, unless that was correct. So 3 and 6, 1 and 1, 0, 6. Oh, it is actually after 100 seconds. So it is 3 and 1, 0, 1, 2, 3 and 1, yeah. 4 and 0, 0, 1, 2, 3, 4. 4, oh, 4 and 0. It should be here, right? 5 and 5, 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. 6 and -1. Oh, -1. Oh, okay. We need to make sure we are within the bounds, so we need to, if you are within the bounds, we need to add that, like, the boundaries, right? So we teleport back to that position. So if, let's say, if x was less than 0, then what we do, we add the width, and if y is less than 0, we add the height. So 3 and 1, 0, 1, 2, 3 and 1, okay. 4 and 0, I'm not sure what is this, but yeah, let's 4 and 0, 5 and 5, 6 and 10, 0, 6 and 10 is wrong, 1 and 3, no, 4 and 9, 0, 1, 2, 3, 4 and 9. Did I set the bound? Oh, so width is 103 or 103 or 109. Let's check it out. Nope, that is this one only. Maybe was this this wrong because I'm certain that it should be x, velocities of x, not that.
सही जाएगा.
6 and 1.
Time लगता है.
So 1 is 4 and 0. That didn't really change anything, did it?
खराब nothing was. क्या बताइए how यार.
I will not do that for 100. Let me first do it for this. So that is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10th element. So 2, 3, 4, 5, 6, 7, 8, 9 and 10. So you should get 5, 0, 5, 0. Five and 6. Nope. 6. So let's try out the other ones, which will be to iterate over all the function, all the place quadrants. So it will be a list of point and that is it, and we need the integer as the score of that, and we'll have q1, q2, q3 and q4 as all zeros. So for robot in range, now we need to check if let's switch case. I want to have one case where the robot x is less than, okay, we need to pass the boundaries, the width, the height as integers. So this will be if it is less than the width by 2 and the y coordinate is greater than is less than the height of 2. So it is in the middle of it. No, it's not in the middle of it. It is like within that range of it, so we need to increment q1. And if the case is so robot of x is less than, so this will still be less than the width, and our coordinate will be greater than this time height by 2, will definitely within that range. So we need to add q2. The case 3 will be in this case we know that the robot's height x position will be greater than the width. So if robot not x is sorry not y is less than the height by 2, we need to increment q3. And okay, we need also a case for it is in the middle of it. So for that I'll do one thing, which will be robot of x will be equal to, let's call it quadrants. So the two coordinates we need to ignore them, so it will be quadrant x and quadrant y. If that is the case, we continue. Else we can replace this with quadrant x, this with quadrant y. Okay, we are back. Not sure what caused that. And default will be let's do q4 plus plus, and we'll return q1 times q2 times q3 times q4. And that is it. And we need to place quadrants, no points. Let's print the code. Yes, sure. This will be, we first pass the width 101 and 103. I'll replace that in the constant in a minute. Uh, okay, let's call it width as 7, height as 11. Oh, that is correct. Yes, it was 12, right? Yeah. So we already have the plot. Let me add 101, right? 101. Okay, answer is too low. Hmm, I'm still not convinced with this. What was the first one? 2154, too low. Let's check this. Mhm. So 20, 19, 18, 17, 16. Okay. Some issue with that. What are we doing wrong here? Oh shoot. 60, it was that pattern. Yeah. Oof. So during the bathroom break, nice if using, if they are same type of robots, they should have a hard-coded destroy very badly. Most of the robots will in themselves a picture of Christmas tree. What? what is this? Like, during the bathroom break, someone notices that these robots are awfully similar to ones built and used at the North Pole. If they are the same type of robots, they should have a hard-coded Easter egg. Very rarely, most of the robots should arrange themselves into a picture of a Christmas tree. What? Oh, what is this? Never mind. How do we figure out it's a Christmas tree? Like what? Is this missing information? Like, what is the fierceness and the select robots to display the Easter egg? Hard-coded Easter egg. Very rarely, and most of the robots would arrange themselves in the picture of Christmas tree. Like, what is that picture of hard Christmas tree? I am not sure. And it's weird. So it is struggling still. 9, 10, 12 still left. So 3 days are still left. But yeah, let's